Good morning to all. So in previous class we have discussed about reversible inhibitors, enzyme inhibitors. So enzyme inhibition in that two types are there. That is a reversible inhibitor and this one is irreversible inhibitor. So in previous class we have discussed about the reversible inhibitor. Okay, so in that two types are there: competitive inhibitor and as well as non-competitive inhibitor. So competitive inhibitor is nothing but here. So if you take enzyme inhibitor and substrate, if you take a inhibitor and substrate concentration, if you increase the inhibitor concentration, so specifically inhibitor will bind into that one and stops the reaction. So that is the about the competitive inhibitor. Okay, in non-competitive inhibitor, so there is no effect of the substrate concentration. Okay, so even in the presence of substrate, so this inhibitor inhibit the activity. So that is the about. So for example, so actually it is having like this. This is the enzyme and it is having active site. It is having active site. Here, this is the inhibitor and as well as this having substrate. Okay, this is about the non-competitive inhibitor. Here, both inhibitor and substrate will be there. Okay, both inhibitor is there and as well as substrate. If you take a competitive inhibitor, what will be happen? There is a competition between inhibitor and as well as a substrate molecule. Okay, so if you increase the concentration of the inhibitor, so inhibitor will go and bind that this active site and blocks that reaction. But in this case here, if you see here, both inhibitor as well as substrate will be there. So there is no competition between substrate and inhibitor. But when inhibitor will go and fit into this one, so then immediately it blocks the enzyme. Okay, it blocks the enzyme. So there is no competition in this one. So thereby it fits into this. So this will be inactive site. Once this inhibitor will go and bind this active site. Okay, so another active site should be in inactive stage. Okay, inactive stage. So that's why what will be happening here. So it will be bind and thereby inhibition takes place. This is about the non-competitive inhibitor. Okay, this is the reversible inhibitor. Two types: competitive and non-competitive inhibitors. Let's see another type: irreversible inhibitors. Okay. Second one, irreversible inhibitor. Okay, irreversible inhibitor. Irreversible inhibitors covalently bind to enzyme. Actually, in a previous one, also what will be happen? There is no chemical reaction between substrate inhibitor and enzyme. But in this case, there is chemical reaction occurs. Okay, chemical reaction occurs means covalently. So it binds covalently. Okay, it cannot bind in reversible. It cannot bind covalently, but here it binds. That is okay. This irreversible inhibitors, irreversible inhibitors covalently bind. How it will bind? Covalently bind to an enzyme, bind to an enzyme, and cause chemical changes. Chemical changes to the active site. What will be happen here? Chemical changes cannot occur in that competitive inhibition, but here reversible inhibition. But here in this one, enzyme cause chemical changes. Okay, chemical changes occurs. Okay, chemical changes to the active site. To the active site. To the active sites of the enzyme, and cannot be reversed. Cannot be reversed. That's why it is called as irreversible inhibitors. Irreversible inhibitors. Okay, cannot be reversed. So once it go and bind that one, so it completely removes that one. Okay, so that's why it is called as irreversible inhibitors. Okay, so in this irreversible inhibitors include modifying key is containing amino acid residues, amino acid residues. Okay, amino acid residues need for the enzymatic all this activity. Okay, so they often contain some functional groups such as aldehydes, alcohols, some halides. So these are involved in this one because chemical reactions occur. So that's why it contains functional groups. Okay, contains functional groups. They often contains. They often contain reactive functional group, reactive functional group, reactive functional groups. Okay, such as what are the groups here? Aldehydes or alkenes and etc. Okay, etc. Okay, so amino acid residues will react with this one. Okay, and so involved in the chemical reaction and remove that one. Let's see the equation. So this is a just 50 minutes class, 15 or 20 minutes. After this, I will start a new chapter. Okay. So just some topics are there. So that's why I want to finish these topics. Enzyme substrate complex and forms the enzyme plus products. Is it or not? Okay. So this is a K1. Okay. EI. K prime 1. Here plus 1, here plus 1. This is the substrate. Both will give the enzyme inhibition. Okay. So for example, um, can I write here? So irreversible inhibitor from a reversible non-covalent competition with the enzyme. Okay, this complex reacts and produce the modified irreversible complex E1. Here, what will be happen here? It removes HX minus HX and forms the. Okay, like this, it forms this one. Okay, it forms this one. The some group. Okay, so it forms the so reaction, chemical reaction occurs because here it removes H and X. Okay, and bind to this one. Okay, so like that here, this will be formed. Okay. So next applications. Okay, this is about the irreversible inhibition. So next one, enzymes in organic synthesis. Enzymes in organic synthesis. Enzymes in organic synthesis. Okay. So in this, how we have to resolve the racemic mixture. Okay. Resolution of racemic mixture. Resolution of racemic mixture. Okay. So let's see how to we have to resolve the racemic mixture. If you take racemic mixture means half of the means 50% products will be found and it is very difficult to separate. Okay, very difficult to separate the mixture. Means if you take R and S, these isomers will be are having the same properties. Only the difference is the plane rotation of plane polarized light. Okay, so if it is having 50% of R, 50% of S, what will be happen here? It is very difficult to separate the R and S isomers. At that time, we have to use the enzymes at the resolution of the mixture, racemic mixture. So for that, we have to use the enzyme. So let's see what will be happening. Okay, suppose here H will be there or and here NH AC. These are the mirror images and which are mirror images enantiomers. Means nothing but here this is the racemic mixture. We have to separate this racemic mixture by using enzyme called deacylase. Deacylase means we have to remove this acyl group. We have to remove this acyl group and it will be separated into okay, racemization. Okay, So next, what will be happen here? This is the racemic mixture. We have to call as racemic mixture. Racemic mixture means half of 50% of this product and 50% of this product. Okay, and by using this enzyme, we have to make one of the enantiomer is in high yield. Okay, so thereby it will be separated easily. Okay, suppose what will be happen? We have to remove this acyl group and introduce the hydrogen. Okay, so means here NH2 will be formed. COOH is there or H plus another group is there NH2. I will write here COH or H. Okay. So after this resolution, it forms some different products, not in 50-50 percentage. So it will be 60 percentage and it will be 10 percentage. That means 40 percentage. So if it is a 50-50 percentage, then it is called as racemic mixture. And by deacylase, by using deacylase enzyme, this is the enzyme which removes the acyl group from this N-acetyl group. Okay, so it has to remove the acylase enzyme. D means removal of acyl group. ACE means enzyme. Okay, deacylase enzyme which removes the acyl group from this one and introduce the hydrogen. Okay, so we'll get back this amine. Okay, it will give after this reaction. It will give some different products. This is the major one, or this is the major or minor. Okay, if it is major, it will be a minor. If it will be a major, if it will be so at that time it will be major. Okay, like that. So it will give two different yields. Okay, after reaction, it gives a different yields. So that's why we can separate easily. So for this purpose, we are using enzymes. Okay, for in this organic synthesis, we can use the enzymes. Like that, we have to use some more examples are also there. Okay, chymotrypsin is there, pyruvate decarboxyl is there. Okay, I will show you. What we have to do? We have to do the hydrolysis. Okay, H2O. For this, it use chymotrypsin. Chymotrypsin enzyme. What will be so? What is the use of this enzyme? It converted this aldehyde into acid. Okay, acid. If you see here, it will be removed. So it will be removed and this CO becomes the COOH group. Okay, COOH group. So by the help of this chymotrypsin enzyme, what will be happen here? We have to do this hydrolysis oxidation process. Okay. So next example. We have to use the pyruvate decarboxylate. Pyruvate decarboxylate. Decarboxylate. Okay. So this will remove the CO2 and form the product. pH. It becomes a OH group. Okay. This becomes a OH group. Okay. So another group is also there, aldolase. Means aldol reaction will be formed. Okay. So I already I have given you notes. So in that you can see that example. Okay. So this is about the enzymes in organic synthesis. Okay. Let's see what is the immobilized enzymes. immobilized enzymes. So immobilized enzymes. The suspended enzymes are difficult to handle because these enzymes as well as products are water soluble. If it is water soluble, how can we separate? So it is difficult to isolate the product and difficult to reuse the catalyst. Okay, if it is water soluble, so what will be happen? It is very difficult to isolate the product as well as the we have to reuse the enzyme because it is a catalyst. So that's why in such causes, enzyme and substrate can be separated by a cation exchange chromatography. So in this situation, we have to use the cation exchange chromatography. Okay, enzymes which are immobilized by attachment to solids. Actually, what is this one? Enzymes which are immobilized which are immobilized. So how we have to by attachment to solids by attachment to solids by attachment to solids support either support either by absorption process by if you use a solid support, definitely there will be adsorption process will be there. Okay, so that enzyme so it can absorb that one and will release that one. Okay, so here adsorption process are by covalent bonding by covalent bonding. Okay, have higher stability have higher stability of products. Stability and products can be easily removed, can be easily separated after reaction. After reaction. Okay, so here enzymes which are immobilized by attachment the solids support either by adsorption or by covalent bonding have higher stability. Or once it will get stability, so we can easily separate that one. Okay, after the reaction. So adsorption is one of the method immobilization of enzymes. So we can easily adsorb that one. In this method, cation exchange. So in this method, cation exchange resins will be used. Cation exchange resins are preferred. Resins are preferred. Resins are so which type of here we are using cation exchange resins. Resins are preferred in this one. Okay, preferred in this one. Immobilization easily make it so we can remove easily. Okay, so let's see some of the examples for this one immobilized enzymes. Okay. Immobilization of cation exchange resin. Immobilization of cation exchange resin. Cation exchange resin. Okay, so let's see. So this is the solid polymer. We are using this one. Okay, COO minus H plus. Okay, so next this is COO minus H plus acid. This is the solid polymer. What it is? Solid polymer. Polymer which is having carboxylic group. Okay, solid polymer. And we are using enzyme. We are using enzyme. Enzyme which is having NH3 plus. Here also NH3 plus. Okay. So what will be there? There is a interaction between this minus and this plus groups. Okay, and forms this one. Here it is having this one. This is an enzyme. Okay. So this solid polymer is attached to this enzyme like this. COO minus here, COO minus here. Okay. So as well as here it is having NH3 plus. Here also NH3 plus. So there is a interactions there here. Okay. So this is the interaction. Okay, cation exchange resin. This is the cation exchange resin. Okay, so next one is immobilization by covalent bonding. Immobilization by covalent bonding. By covalent bonding. Okay, so in this we have to take solid support. This solid support here it is having lactone gum. Okay, when it reacts with HCl, actually this is a nylon, which is a this one. Okay, so this HCl breaks the bond and form the NH3 plus NH3 plus Cl minus, and here it is form the COO minus. Okay, this is the nylon, which when react with base, what will be happen now? One of the hydrogen will be removed, means HCl will be removed. Okay, HCl will be removed minus HCl and form the NH2 here, and this is the COO minus. What about here? This is next. After this one, when react with this products, here CHO group is there. Here also CHO group is there. Okay. So next we have to use the enzyme also, which is having NH2 and NH2 group. Okay. This is the enzyme. Okay. So what will be happen? This reaction. This is attached to this one. Here COO minus we have to write here N. Here also N means it forms first this one. CHO is there and also CHO is there. It forms one adduct. This double bond. This is the product after enzyme. It forms this one. Okay, this forms this product NH2. NH2 will be there. It forms first. It removes water molecule and forms the C double bond N, and here also C double bond N 1. Okay. Here NH2 group is there. Okay, I will tell you. Next one, Corning jam. This is the solid support which is having amine group. Okay, here we are using CHO. Here also CHO. This is the enzyme which is having NH2 group. Okay, it forms SiO. Here this N double bond. It forms. It removes this one. Okay, H2O. So what will be happen here? There is a double bond formed between this C and this N. Okay, so that is nothing but that one. Okay, so next. And forms the again double bond N which is attached to enzyme. Another N. This N will react with this NH2 and forms this one. Okay, so that is one of the reaction. If it reacts with ClCl, what will be happen? It removes this one Cl. So next forms the N C double bond. Yes, if it is attached to enzyme, enzyme. So what will be happen here? It forms. NH C double bond. Yes. NH which is having attached to enzyme. So this is the another one. Okay. So by this we have completed the proteins and enzymes. So I will share another link. So this class I want to end now. Next I will share link. Please be in online. Okay.